Booz Allen is happy to sponsor Eric Newton and giving perhaps one of the most technical sponsored talks we'll hope you'll ever see. I've had the pleasure of working with Eric for a number of years on different client projects, and the amount of information that I've learned from Eric about how Accumulo works and the intricacies of its internals have consistently blown me away. So I hope to share a little bit of that with you for this session. If you guys are interested in learning more about Booz Allen and what we're up to, please talk to me after the session or visit us at our booth at the corner right over there. We have some great demos to give and happy to talk about the other work that we're doing. All right, but for now, here's Eric talking about bulk import and Accumulo.
Okay, so this talk is going to be mostly historical and a little cathartic for me because I'm going to be talking about all the things we screwed up. And so hopefully it's a little bit of lessons learned, and if you have some distributed computing to do, maybe you'll learn from our mistakes. So let's talk about ingest for Accumulo for just 1 second. I know this is review for everybody, but when you want to put something in Accumulo, you make up a mutation and you throw it at the tablet servers, and what happens after that is that it goes into the read-ahead log so that we always have it, and then we stick it in memory, and when the memory gets full, we write it to a file, and we merge and rewrite the data as necessary. But keep in mind that this kind of, this level of live ingest requires at least 2 writes, one to the read-ahead log, you have to do this small in-memory sort, and then a flush to disk. We can do better. If you're using Accumulo, your problem probably requires heavy ingest. I know ours do. So one way you can avoid this double write is to use MapReduce efficiency. So if you take your incoming data and you run it through MapReduce and pre-sort it and create the files that Accumulo uses natively, these R files, you can just hand the file over to Accumulo and you're done. It's a one little operation. This requires just the one write, and you get much larger sorts. And you get to use the power of the entire cluster on your data. So we thought that was a pretty cool hack, so that's what we did, a little hack. So the version 1 of bulk import was to build the R files. We're just going to ignore how we do that. But once you had an R file, you stick it in a directory, tell Accumulo about it, and it will magically put it against all the different tablets in the entire system. And the first version of this we did client side. So when you asked it to import the directory, your code, your threads on your client were reading that file and talking to Accumulo tablet servers directly. So one negative aspect of this is that you only had the one client doing the work. So it didn't really scale very well unless you just fired up lots of clients throughout your cluster. In addition to that, the clients also had to handle all of the retry logic, and if your client died, then your bulk import failed too. So here's all the problems that I was alluding to. Bulk import in the client is limited to the client's computational power. Something that we ignored for a very long time was permissions. We just had everything kind of running as the HDFS super user, and everything just kind of went in because everybody could read everybody's files. One unfortunate thing is that a file could be added to a server multiple times. You could add the file, maybe it would be compacted out, and then you'd have to add the file again, and then the same data would get ingested multiple times, and if you had aggregators or something that looked at the data multiple times, it would just be all messed up. And like I mentioned, if your client fails, there's no retry. Your client just dies. So we had to fix the permission problem. So, you know, if you work for the National Security Agency, it would be nice to have some of that security. So in version 1.1, we basically moved the client code to the master, and the master would do the bulk imports, and that fixed the permission problem, because by handing the file over to a process that had the ability to read and write into the Accumulo area, we now had a better permission system. In addition to that, we created a testing infrastructure, our random walk test suite, and we added a test for bulk ingest, in which I will describe. So this test is trying to determine whether or not we did bulk imports correctly. So we create a sorted file of ones. So we'll have a key like 1, 2, 3, 4, 5, 6, 7, 8, and it points to 1. And we create an identical file with the same random keys with a -1. And then we would just randomly bulk import these things into the system, and assuming we imported all the files correctly, we should be able to sum all of those and get back 0 for every single row. A little bit about random walk. Random walk does crazy things to Accumulo all the time. So while in this test, we would import these files in a random order, at the same time, we're also randomly splitting the tables into different segments. We're killing tablet servers, data is moving around, and we might even be running a random walk test, another test, completely different test on the same system. So while we're doing this, we're also doing it on a larger cluster, so we have lots of clients and lots of servers, and this is all computationally intensive. And the test found many problems. So to get away from our sort of limitations on a single client in bulk importing the files, we have a new bulk import process. So now, when you hand the file off, it goes to the master, and the master then distributes the work for processing that file to an arbitrary tablet server. So this just spreads all the work out across the whole system. And this is starting to get complicated, so I believe my only picture is coming up here. So the first step, your client wants to add some R files into the system. Tells the master, here's the R files. The master hands it off to a tablet server, which is just a slave node, just there to do some work. And that tablet server analyzes the files it's been handed, and it in turn talks to the other tablet servers. Okay, so it's a little complicated, multi-step process there, but it distributes the work of analyzing the files and then handing it to the tablet servers who are supposed to incorporate those files into their tablets. So this is great. We solved some problems. We got the master taking care of the permissions, we've distributed our processing, and we tested the snot out of it, and it didn't do so well. So 3.0. We wanted to solve some problems like a lot of the defensive programming of bulk ingest required us to talk to the name node. So as you're bulk importing, we would create these flags on the file system to say, oh, file garbage collector, ignore these files for right now because I'm bulk importing. And so as we're doing garbage collection of the files, we have to keep asking the name node, is this a bulk import file? And if it is, then leave it alone. We had to make sure that our bulk imports were not repeated, and all this sort of management of the overhead of knowing what's going on during a bulk import was we moved from storing it in like HDFS and moved it into the metadata table. And then we tested it, and it didn't do so hot. Because of this one last problem. So I think the easiest way for me to sort of describe how this problem goes, and it's a complicated thing, is in a sort of conversation between the tablet servers that are loading the file and the tablet servers who have analyzed it and are trying to get the file loaded. So the tablet server that is loading the file finds out who's supposed to have it, goes and talks to it and says, please take this file, incorporate this into your tablet. And that tablet server says, oh, I have never seen this file before, I will incorporate it. And then goes to sleep for some arbitrary amount of time because it's got better things to do. The initial tablet server doesn't hear back, times out, and says back to the server, hey, take this file again, what's wrong with you? And it's a different thread that wakes up inside that server and says, hey, I never saw this file before. Got it, thanks, acknowledges, tells the other tablet server, I got it. May even do something like compact the file, incorporate it into its other files. So it doesn't even have a reference to the file anymore. And that's when our sleepy thread wakes up and says, oh, I have a file to incorporate into my other files. And now you've gotten that file imported twice into the same server. So to fix this, we added a third-party negotiator. So before the tablet servers incorporate files into their set of files, they contact Zookeeper, another third party in this distributed system, and ask, is this session for this bulk import still active? And if it is active, it will incorporate it. And if it's not, it blows it off. And the tablet server, or the master, before it shuts down the whole thing, or the whole bulk ingest, contacts all of the tablet servers to verify that nobody is currently processing this particular session. So with all these checks and balances between keeping track of what's to be bulk imported, what has already been bulk imported, and currently active sessions, we were able to guarantee that files are bulk imported once and only once. So the way the session works is that instead of just handing a file off to the tablet server and saying, take this file, it says, take this file, but for this particular session. The tablet server keeps track internally in memory, hey, I'm now working on this session, and I've never seen this file before. And if it goes to sleep, that's okay. Because when the tablet server comes around again, it says, take this file for this session. It says, I never saw it before, and it can incorporate it. And before the tablet server shuts down, the master goes through and makes sure that nobody is already processing this. So if the sleepy thread wakes up, it will double check for the session ID, see if it's still active, and if it is, it won't incorporate the file. Or if it is not still active, it won't incorporate the file. And once the master double checks that nobody's currently working on the session, it can do all the cleanup for all this overhead, this metadata information that we're keeping track of. So this solves our problem of having distributed processing, being able to use the power of our whole cluster to analyze our R files and get them incorporated. Handles the permissions being correct because we aren't having the client do anything under the covers in the Accumulo file system. Files get imported once and only once, and the markers get cleaned up even in the face of failures. But there were still problems. When we initially tested bulk import, we did it at a scale of, say, 10 machines, 100 machines, something like that. When you go larger than that, as we do, the performance was not so good. In fact, it turns out that having the master move the files in underneath Accumulo meant that the master was performing this many HDFS operations, but that one master was competing against the entire rest of the cluster. So if you have 1,000 nodes making requests to the name node to move files around, and one master making one request at a time, it just couldn't get enough purchase on the name node to get a lot of work done at once. So master go faster. We added a configurable thread pool to the master so that it can make hundreds of requests to move files, and so we can push more work to the name node, and you can, in a group commit, get more stuff done at once and compete against the other 1,000 nodes that are in the cluster. So in summary, bulk import, it's a more efficient way to do data ingest. It sounds easy. you're just taking a file that's already sorted, completely ready to use, and just handing it over to Accumulo, but it's a lot harder than you think, because consistency is hard in a distributed system. And testing, and testing, and testing is what helped us beat out all of these small problems. And then finally, when you go big, you just can't predict exactly what kind of problems you're going to have. Who would know that moving a bunch of files over would be your bottleneck at the end? Okay, that's it. Any questions? It's waiting synchronously, but it has multiple threads to do that job. Yeah. No, I had enough other problems. Yeah, I suppose you might get some of that if you're producing your R files with MapReduce and you get your locality and your regions correct, but no, nobody's working on that. Because the master's not actually doing any work, the master is just coordinating. So when it's moving those files, it's just moving files over. I mean, it itself isn't doing any work. The name node is doing a commit to move files around. Well, we've actually known this for a while, that if you push more work to the name node at one time, you can get it to do more work, because those things will be collected by the name node into a single commit into the edit log. So it can actually get more work done than if you say, move, wait for the response, move, wait for the response, move, wait for the response. And it does help to compete and get timely moves done to compete against the rest of the cluster. If you have 1,000 other servers making requests to the name node, and you're just getting a little tiny slice of that, it can just take a while. So even if the resources are there, you could. The master's coordinating everything through the fate framework, and so that's sort of a highly redundant. And so it kind of can keep track of what state it's in. So I guess we could have moved fate to the tablet servers and had it do the move too. It's also been brought up that since everything is in a directory, we can move the whole directory and not even rename the files. But it's been, practically it's been very useful to have the files named in a certain pattern. So we can just know from a glance where the file came from, how it was incorporated, and it gives us clues as to what's going on in the system. But that was an alternative. If the thread thing didn't work out, we were going to have to do that. So if you have half of your bulk import fail, then the file ends up in the failures directory. And since you already have made one reference to it, it has to copy it. So it copies it into the failures directory. And that's distributed too. So we distribute the copying of files into the failures directory, so it's scalable as well. Yes. So at the end, when the master is figuring out what failed, what succeeded, it can look at the metadata markers that we've made to say that we've already imported these files, and it will know whether it was actually incorporated into one of the tablets. And so then it will have to copy it. If it sees no references to it because, I don't know, the file was corrupt and nobody could use it, then the file is moved into that directory. So this marker is actually separate from the marker we use to keep track of files. They're bulk markers that tell you that this file has been incorporated into the tablet. I was expecting so much more. Anyone else? Okay, thank you. If you have any questions about bulk import, I can bore you to tears.